For generations, human cultures operated on ecological balance. The requirements of modern scale replaced that balance with aggressive, continuous extraction. Since the dawn of the 19th century, industrial progress followed a zero-sum trade-off. Producing more goods required burning more fuel and drawing more water. Whether electrified by the grid or automated by early computing, the ledger remained the same. Output increased, and environmental consumption scaled alongside it. That ledger is now hitting its limit. Global climate thresholds, water stress, and carbon accountability are written directly into international trade agreements, corporate compliance laws, and investment mandates. The physical limits of the Earth have become legally binding constraints. The historical model of treating natural resources as infinite, deferred costs is financially and ecologically exhausted. Building a method of growth that does not strip the environment has become a strict operational requirement. Identifying where the waste occurs reveals a hidden drain on these facilities, the physical and financial cost of unplanned equipment breakdowns. This chart shows the massive toll of reactive maintenance. Every year, unplanned downtime costs the world's 500 largest companies roughly $1.4 trillion, or 11% of their combined global revenue. Artificial intelligence is proposed as the solution to this inefficiency. However, the computational infrastructure required to run these models generates its own environmental footprint. The left side of this infographic shows global data center power demand doubling by 2030 to 945 terawatt-hours, exceeding Japan's entire power grid. A single data center can require the electrical capacity of 2 million households. We cannot stabilize global manufacturing if the computational power required inadvertently triggers a secondary energy crisis. The solution lies in resource-just intelligence. This is the specific ability to decouple economic growth from physical resource consumption, breaking a 2-century-old industrial rule. When applied to industrial processes, the financial upside is immense. McKinsey research projects that integrating generative AI could add between $2.6 and $4.4 trillion to the global economy annually. The right side of this infographic illustrates how this dividend is earned. AI observes millions of operational variables, from supply chain logistics to electrical grid loads, and optimizes them simultaneously, finding efficiencies no human planner could calculate in real time. Previous automation followed rigid calendar-based rules, replacing parts on a fixed schedule, whether it was needed or not. AI operates on evidence-based judgment, adjusting physical processes second by second based on actual conditions. Engineering a system to produce higher volumes of output now physically requires less energy, less water, and fewer raw materials than running it blindly. We can see exactly how this works on the factory floor by looking at the management of heavy physical assets. Historically, heavy manufacturing relied on reactive maintenance. A facility runs a massive rolling mill or blast furnace until a part physically breaks, causing an emergency shutdown and ruined materials. Predictive maintenance replaces that guesswork. By embedding sensors that track vibration, acoustics, and thermal signatures, AI models analyze component stress and identify exactly when a fracture will occur. The results are highly measurable. Deloitte's analysis of structured industrial deployments shows that this predictive approach reduces catastrophic machine breakdowns by 70%. Monitoring systems yield an average 25% gain in overall equipment productivity. The system then moves from predicting to prescribing. The AI evaluates production loads and safety constraints to recommend the exact intervention needed, ensuring functional parts are never discarded prematurely. Avoiding a blast furnace stoppage saves millions in revenue, but it also eliminates the massive carbon emission spike required to restart a cold furnace. Forecasting mechanical failure is a direct mechanism for reducing industrial carbon footprints. This chart from the World Economic Forum addresses the immediate concern regarding AI integration: workforce displacement. While legacy roles will be displaced, the data projects a net positive global gain in jobs created by 2030. To ensure local job security, industrial integration must follow a doctrine of augmentation. The AI acts as a diagnostic assistant, extending human intelligence rather than replacing the human operator. This requires a strict governance architecture. Every algorithmic recommendation that impacts plant safety, environmental discharge, or employment must escalate to a legally named human engineer who owns the final decision. That architecture must also mandate strict data sovereignty. Information generated by facility sensors and the operational data of the workers themselves must be governed by clear consent and localization rules, consistent with India's Digital Personal Data Protection Act. When these legal and auditing frameworks are embedded directly into the software, the technology is constrained to serve the workforce, reinforcing human oversight. Testing and scaling this blueprint requires a specific environment, and the state of Odisha serves as a highly capable national proving ground. The region combines a legacy footprint in steel and mining across districts like Jajpur and Rourkela, with a booming digital IT sector in Bhubaneswar. The roadmap for these facilities begins with diagnosis and digitization. Before any software is purchased, legacy plants must install sensor grids to map operational bottlenecks and capture reliable physical data. The final stage of that roadmap is institutionalization. By establishing continuous reskilling programs and rigorous auditing cycles, facilities ensure that these initial technological upgrades translate into permanent environmental and operational gains. Productivity now represents a broader standard: maximum sustainable value from minimum resource intensity. The deployment of industrial intelligence creates the capacity to produce better, eliminating waste, preserving ecosystems, and elevating human dignity.